Sharks swim in our deepest thoughts and imaginations. They are creatures of ancient mystery and primal power. For many people, the very word shark brings a chill. This fear is often learned, fueled by dramatic stories and sensational movies. However, this fear often overshadows a deeper truth about these animals. They are not simply monsters of the deep. They are complex, fascinating beings that have survived for eons. Understanding them is key to appreciating their true nature. Beyond the fear, sharks also inspire a profound sense of awe. They are perfectly adapted to their underwater world. Their movements can be swift and precise or slow and deliberate. Observing a shark in its natural habitat is an experience of pure wonder. They are a testament to the power of evolution. They have roamed the oceans long before dinosaurs walked the earth. This long history makes them living archives of the planet's past. We are only just beginning to uncover their many secrets. The human relationship with sharks is complicated. For centuries, sailors and coastal communities have shared the waters with them. Sometimes these encounters were peaceful, other times they were frightening. These interactions have woven sharks into our folklore and our art. They symbolize danger, but also strength and resilience. This dual perception makes sharks particularly captivating subjects of study. We seek to unravel the facts from the fiction that surrounds these magnificent predators. Our goal should be to replace uninformed fear with informed respect. Sharks are not the villains they are often portrayed to be. They are vital components of the marine ecosystems they inhabit. Learning about their lives, their behaviors, and their importance can change our perspective. It can transform fear into a drive to protect them. The more we learn, the more we realize how much the ocean needs its sharks. Their story is one of survival, adaptation, and critical ecological roles. Sharks are often called apex predators. This means they're at the top of the food chain in their environment. This position is not one of mere dominance, it is one of crucial responsibility. As top predators, sharks play a vital role in maintaining the health of ocean ecosystems. They help to regulate the populations of other marine animals. Without sharks, the delicate balance of marine life can be severely disrupted. Their presence is a sign of a healthy ocean. One of their most important jobs is culling the weak and the sick. Sharks tend to prey on older, injured, or diseased individuals in a fish population. This might sound harsh, but it is incredibly beneficial. By removing these less fit animals, sharks help to prevent the spread of disease. They also ensure that the strongest and healthiest individuals survive and reproduce. This strengthens the gene pool of prey species, making them more resilient over time. This natural selection is essential for vibrant marine life. Sharks also influence the behavior of their prey. The presence of sharks can prevent other species from overgrazing certain areas. For example, sea turtles or large herbivorous fish might avoid areas where sharks are common. This allows seagrass beds and coral reefs to flourish. Without this fear factor, these important habitats could be damaged by too much grazing. So sharks indirectly protect these critical nursery grounds for many other marine species. Their influence extends far beyond their direct predation. The ecosystem services provided by sharks are diverse and far-reaching. They contribute to biodiversity by preventing any single species from becoming too dominant. This creates space for a wider variety of life to thrive. When shark populations decline, we often see negative consequences ripple through the entire food web. Smaller predators might increase in number, depleting populations of smaller fish. The ocean is a complex web of interactions, and sharks are key threads holding it together. Their role is truly indispensable. The influence of sharks extends to the very structure of marine communities. Think of them as the ocean's managers or regulators. They prevent middle-tier predators from becoming overly abundant. If shark numbers fall, these mid-level predators, like smaller sharks or large groupers, can increase. This might seem good at first, but it can lead to problems. These emboldened mid-level predators can then decimate populations of smaller herbivorous fish. This has cascading effects throughout the entire ecosystem. When herbivorous fish populations decline, algae can grow unchecked on coral reefs. Excessive algae can smother corals, blocking sunlight and preventing their growth. Healthy coral reefs are vital for countless marine species. They provide food, shelter, and breeding grounds. So, by controlling the predators of algae-eating fish, sharks indirectly help to keep coral reefs healthy. This complex chain of interactions shows how interconnected marine life truly is. The removal of a top predator can have unforeseen and damaging consequences. Sharks also play a role in nutrient cycling in the ocean when they prey on animals. They help to distribute nutrients through the water column. Their movements, often over large distances, can transport nutrients from areas where they are abundant to areas where they are scarce. Even their carcasses, when they die, provide a significant source of food and nutrients for deep-sea scavengers. This contribution to the ocean's nutrient budget is another often overlooked aspect of their importance. Every part of their life cycle contributes to the ocean's health. Consider the vastness of the ocean. Maintaining balance in such a huge and complex system is a monumental task. Sharks, through their diverse feeding habits and wide-ranging movements, contribute significantly to this stability. Different shark species specialize in different prey. Some eat fish, some eat seals, some eat crustaceans, and some even filter plankton. This diversity in their diet means they exert a regulatory influence across many levels of the food web. Their collective impact is what makes them such effective guardians of marine equilibrium. Sharks are renowned for their incredible hunting abilities. These skills are not born of mindless aggression, but of highly evolved senses and strategies. One of their most famous senses is their keen sense of smell. Sharks can detect tiny amounts of blood or other substances in the water from great distances. Some species can detect a single drop of blood in an Olympic-sized swimming pool. This allows them to locate potential prey, even in murky water or from far away. Their nostrils are used exclusively for smelling, not for breathing. Another remarkable sense is their ability to detect electrical fields. All living animals produce weak electrical fields through muscle contractions. Sharks have specialized sensory organs called ampullae of Lorenzini. These are small jelly-filled pores, mostly concentrated around their snouts. These organs can detect the faint bioelectric fields produced by hidden or buried prey. This sixth sense allows them to find fish camouflaged against the seabed or buried in sand. It is an extraordinary adaptation for locating food. Sharks also have excellent hearing. Sound travels faster and farther in water than in air. Sharks can detect low-frequency sounds like those made by struggling fish from considerable distances. This helps them to zero in on potential meals. Their ears are internal, located on either side of their head. They are particularly sensitive to the kinds of irregular pulses that injured animals might produce. This auditory acuity is a crucial tool in their predatory toolkit, guiding them towards vulnerable targets. Vision also plays an important role for many shark species, especially in clear water and at close range. Shark eyes are well adapted for seeing in low light conditions. They have a layer behind the retina called the tapetum lucidum. This layer reflects light back through the retina, increasing light sensitivity. This is similar to what cats have, giving their eyes a reflective glow. While their vision might not be as sharp as some other predators, it is perfectly suited for their underwater environment and hunting needs. Section 5, built for predation, astonishing adaptations. Beyond their acute senses, sharks possess a range of physical adaptations that make them formidable predators. Their streamlined bodies are designed for efficient movement through water. This hydrodynamic shape reduces drag, allowing many species to swim at high speeds with minimal effort. Fins provide stability, steering and thrust. The powerful caudal fin or tail fin propels them forward. Different shark species have differently shaped tails, reflecting their specific swimming styles and hunting strategies. For instance, fast-swimming sharks like macos have crescent-shaped tails for speed. Shark skin itself is an engineering marvel. It is not smooth but covered in tiny, tooth-like structures called dermal denticles. These denticles are oriented to reduce turbulence and drag as the shark swims. This unique skin structure also provides protection. It's so effective that swimwear designers have tried to mimic it to improve human swimming speeds. The texture of shark skin feels smooth if rubbed from head to tail, but rough if rubbed in the opposite direction. This is a testament to its specialized design. Of course, no discussion of shark adaptations is complete without mentioning their teeth. Shark teeth are legendary, and for good reason. They are constantly replaced throughout a shark's life. When a tooth is lost or broken, another one moves forward from rows behind it to take its place. A single shark can shed tens of thousands of teeth in its lifetime. The shape of a shark's teeth varies greatly depending on its diet. Some have sharp, pointed teeth for grasping fish. Others have flat, crushing teeth for eating shellfish. Many sharks employ camouflage and ambush tactics. Species like the angel shark or wobbegong have flattened bodies and skin patterns that blend perfectly with the seabed. They lie in wait, almost invisible, until unsuspecting prey comes within striking distance. Other sharks, like the great white, use countershading. Their backs are dark, blending with the deeper water when viewed from above. Their bellies are light, blending with the brighter surface when viewed from below. These adaptations make them masters of surprise in their underwater realm. Section 6, more than just teeth, scientific insights. Scientific research continually unveils fascinating facts about sharks, highlighting their importance. One key insight is their slow growth and late maturity. Many shark species take many years, sometimes decades, to reach reproductive age. They also tend to have few offspring compared to bony fish. For example, a great white shark might not reproduce until it is over 15 years old and may only have a few pups at a time. This life history strategy makes them particularly vulnerable to overfishing. Their populations recover very slowly from depletion. Sharks are also incredibly diverse. There are over 500 known species of sharks. They range in size from the tiny dwarf lantern shark, which is smaller than a human hand, to the enormous whale shark, which can grow up to 40 feet or more. The whale shark, despite its size, is a filter feeder, consuming plankton and small fish. This incredible diversity means sharks occupy a wide array of ecological niches. They live in all oceans, from shallow coastal waters to the deep sea and from tropical reefs to polar regions. Scientists use various methods to study sharks. Tagging studies, using satellite tags and acoustic transmitters, help track their movements and migrations. This data reveals that many sharks undertake long journeys across entire ocean basins. Understanding these migration patterns is crucial for effective conservation, as sharks often cross national boundaries. Genetic analysis helps scientists understand population structures and evolutionary relationships between different shark species. These tools provide invaluable information for their protection. Furthermore, sharks have remarkably robust immune systems. Scientists are studying shark cartilage and other tissues for potential medical applications. While this research is ongoing, it underscores another reason to value these animals. They have survived for over 400 million years, weathering mass extinctions and dramatic environmental changes. Their resilience is encoded in their biology. Learning from them could offer benefits beyond just understanding marine ecology. They are a storehouse of evolutionary success stories. Section 7, the ripple effect, why sharks matter deeply. The importance of sharks extends deeply into the health of the entire planet. As we've seen, they maintain balance in marine ecosystems. When this balance is upset by declining shark populations, the consequences can be severe and widespread. These are often called trophic cascades. This term describes the chain reactions that occur when a top predator is removed from an ecosystem. The effects can ripple down through multiple levels of the food web, leading to unexpected and often undesirable changes. For example, the decline of large sharks in some areas has led to an increase in the populations of rays, which are one of their prey. These rays, in turn, consume large quantities of scallops and other shellfish. This has caused the collapse of valuable scallop fisheries in some regions. This is a clear example of how the removal of sharks can have direct economic impacts on human communities. The ecological health of the ocean is directly linked to human well-being and livelihoods. Protecting sharks means protecting these resources. Sharks also contribute to the health of crucial coastal habitats like seagrass beds and estuaries. By regulating populations of herbivores, they prevent overgrazing of these important ecosystems. Seagrass beds are vital nurseries for many commercially important fish species. They also help to stabilize sediments and improve water quality. Estuaries, where rivers meet the sea, are also incredibly productive environments. The presence of sharks helps to maintain the integrity of these habitats, which support a vast array of marine life and provide coastal protection. Beyond their direct ecological roles, sharks contribute to healthy oceans, which in turn support us. Oceans produce a significant portion of the oxygen we breathe. They regulate global climate patterns. They provide food for billions of people. A healthy, resilient ocean is better able to perform these vital functions. Sharks, as keystone species, are integral to maintaining that health and resilience. Their conservation is not just about saving a single group of animals, it is about safeguarding the health of the entire marine environment and, by extension, our own future. Section 8. Beyond the Jaws, Understanding Shark Behavior. The popular image of sharks as mindless, aggressive killing machines is largely a myth. This misconception has been perpetuated by movies and media stories that focus on rare negative encounters. In reality, shark behavior is complex and driven by the same basic needs as other animals: food, reproduction, and survival. Most sharks are naturally cautious and will often avoid humans. Attacks on humans are exceedingly rare events, despite the millions of people who swim, surf, and dive in the ocean every year. Scientists who study shark behavior observe a wide range of social interactions and patterns. Some species are solitary, while others form schools or aggregations, sometimes for hunting or mating. Hammerhead sharks, for example, are known to gather in large schools. There is evidence of communication between sharks, though it is not yet fully understood. They use body language, such as arching their backs or lowering their pectoral fins, to signal intent or agitation. These are not the actions of simple, unthinking creatures. When sharks do bite humans, it is often a case of mistaken identity. A surfer on a board or a swimmer thrashing at the surface can look similar to a seal or a sea turtle from below. These are typical prey items for some large shark species. Most bites are hit-and-run incidents where the shark bites once, realizes its mistake, and swims away. This indicates that humans are not their preferred food. If sharks truly hunted humans, the number of attacks would be vastly higher. Understanding true shark behavior is essential for promoting coexistence. By learning about their habits, their feeding times, and the areas they frequent, we can reduce the already low risk of negative encounters. Simple precautions like avoiding swimming at dawn or dusk when sharks are more active, or not swimming near fishing activity, can further minimize risks. Education is key to dispelling the myths and fostering a more accurate and respectful view of these ancient and important animals. They deserve our understanding, not our unfounded fear. Section 9. Protecting the protectors, the urgent need for conservation. Despite their ecological importance and ancient lineage, many shark populations around the world are in serious trouble. The primary threat they face is overfishing. Sharks are caught intentionally in targeted fisheries, but many more are caught unintentionally as bycatch in fisheries targeting other species like tuna or swordfish. Their slow growth rates and low reproductive output mean they cannot recover quickly from such intense fishing pressure. Millions of sharks are killed each year, a rate that is unsustainable for many species. A particularly destructive practice is shark finning. This involves catching sharks, cutting off their fins, often while the shark is still alive, and then discarding the body back into the ocean. The fins are used to make shark fin soup, a luxury dish in some cultures. This wasteful and cruel practice has decimated shark populations globally. International efforts are underway to ban finning and regulate the shark fin trade, but much more needs to be done to effectively protect sharks from this brutal exploitation. Habitat degradation and climate change also pose significant threats to sharks. Pollution, coastal development, and the destruction of coral reefs and mangrove forests reduce the availability of food and critical nursery areas for young sharks. Climate change is altering ocean temperatures and chemistry, which can affect shark distribution, prey availability, and reproductive success. These compounding stresses make it even more difficult for shark populations to thrive or recover from overfishing. The conservation of sharks is a global imperative. It requires a multifaceted approach, including sustainable fisheries management, the establishment of marine protected areas, stronger regulations against finning, and public education to change perceptions. We must recognize that healthy oceans need sharks. By protecting these magnificent predators, we are not just saving a group of animals. We are safeguarding the balance of marine ecosystems, the livelihoods that depend on them, and the overall health of our planet. Their future and ours are deeply intertwined.